then 1/2 and 1/4 like this. Now, our idea is how large of the amoeba world. We count the total sum and reduce the prison area. If outside the prison is larger than 1, then he have chance to go run away. If in outside the prison is less than 1, so it's impossible. Okay, let's count. For this one, 1 plus half plus 1/4, this is a sequence. The total sum is 2. This total sum is 2. And then 1/2 and 1/4. Okay, totally, the amoeba world is 4. The prison area, this prison area is 2 and 3/4. So, yeah, the outside of the prison is 1 and 1/4. Yeah, it seems have a chance to run away. But wait, you must consider a very important property. This one, go out, this one. Okay, when it's run out, you see, if one amoeba in the circle place, the value is 1/8. If he don't move, all the right-hand side square are west. If he one step ahead, this 1/8 be west. So, in this way, it must weight 1/8. And by symmetry, another 1/8 will west. So, the total area, the sum is 1. But from here, we can put it is impossible. The amoeba cannot using final step to run away. Why? Outside the prison, the area is enough for amoeba, right? But why it is impossible? Because outside of this, the square is infinity. Is it? So you must using infinity step. So it is impossible succeed in final step. Okay? So this impossible. Okay, for the beetles, we jump this. We using y equal x squared. So we can assign like this. This x squared, x cubed, like that. And the total sum of amoeba square is x 5 power plus 6 power plus 7 power, like this. And the sum of this side is this. So its total sum is x4 squared is 1. The total sum is 1. So also cannot succeed in final step. Okay, we wish to determine all the prisms from which great escape achieved. We define prism as a consists of the southmost AI square in I, the column I less than n, such that A1 is larger than A2, larger to AN. Then we can see this is possible. And also, because its sum is 1, only 4 squared in 4 step. This 12, and this also impossible. Okay. We can prove this also impossible. For the Beatles, we can download the side. The original problem, D is equal 4. Now we can start from 0. From 0, D equals 0, only 2 Beatles enough. If D equals 1, we need 4. If D equals 2, we need 8. For D equals 3, we need 20. We need 20. Okay? So, how about the 4? D equals 4 is impossible. So how to prove this? Yeah, we have a research. It is impossible. Then we extension the problem. The original is go outside. Now the research problems go inside. So how to solve this question? I leave the research problem to the student. So the room is 10 square. Is it possible? The room is 50 square. Is it possible? Till 35 square is possible. That's this is my report today. Sorry, the time is very limited. So if you are interested, I can copy I can send my lecture document into the group. Okay, thank you very much.
Thank you very much, sir. Thank you for the interesting talk. We hope that the Beatles did not escape in this room. The next talk will be about how to make polyhedra using binder clips by our jury member Xinpo Wang from Taiwan University.
Okay, so thank you for all the waitings. My name is Simple Wang. I was a postdoc in Berkeley, but now I'm getting a job at National Taiwan University, so I'm becoming an assistant professor. So in any case, that's about my background, and I want to share with you about some binder clips. Okay, so it works. So let's begin. You all have binder clip. If you don't, just report to the students. But before we start playing, okay, this is like a workshop. This is like more or less a mathematical workshop. So I'm obligated to talk about, you know, the mathematics part, some of the mathematics part. So the polyhedra all begin with the Platonic solid. So this is like the ancient Greek people. They believe that God created the world using beautiful mathematics. So they kind of believe that the stars they see on the sky follow very simple rules. So for example, on the right-hand side, you see 5 layers of polyhedra. There are tetrahedra, cubes, octahedra, isochihedra, and dodecahedra. So they believe that each of the hedras correspond to some of the planet, the Venus, the Mars, the Earth, the something and something. So they kind of believe in that. And of course, we know it's not true. We know that the planet is just orbiting the sun using some arbitrary orbit. But it doesn't matter. It's like some ancient belief. So here are a list of polyhedra. The tetrahedra, where tetra stands for 4, is a polyhedra with 4 faces, 6 edges, and 4 vertices. The second one is cube. Often we call cube, but a more formal name is hexahedron. So hexa means 6. It has 6 faces. Octahedron has 8 faces. All of them are triangle. Dodecahedron has 12 faces, 12 pentagon. Penta equals 5. Penta means 5 in Greek letter. 30 edges, 20 vertices. Why am I reporting this number? Because these numbers are very interesting. When you want to use binder clip to build polyhedra, you need to know the count. Okay, so in our case, we want to know how many edges each polyhedra has. If we want to build a dodecahedron like this one, we will need to build 30 edges. And then we will need to use 60 binder clips, and so on and so forth. And the last one is isochihedron, okay, which is the dual of the previous one. So let's get into you are all waiting. I don't want to keep you waiting. Let's get into the business. This is binder clips, okay? You all have binder clips. Please start using them. I'm calling this thing the X edge. I'm not sure if you can see that. So I'm going to zoom in, okay, so you can see better. But this is about the best I can do, which is fine, because I have this thing. I need to get to the other side, okay? So this is what I call X edges. Okay, you replicate that, very good. Okay, so this is X edges. You've seen that? This is yeah, you got it. Yeah, this is an easy one. It will get harder. Okay, so I'm not treating you like you're 5 years old or something. So yes, very good. Okay, this is it. Yes, very good. This is it, very good. Not good. Someone has to move my, yes, very good. Thank you. Here's the simple, and here's the simple. Yes. Okay, very good. Okay. You need 12 of this, 12 edges, because each one is one edge, and in order to build a cube, you need 12 edges, right? A cube has 12 edges. Right? This can be found on the Wikipedia. So you need 12 of this. It's going to take a while. So let me just okay. Okay, let me just show you it's a representation of what I want. You are supposed to build 12 of this. And of course, feel free to cooperate, right? This is meant to be a cooperative activity. My projector is not working, but that's okay. You all know what you should be doing. Is there any question? Oh. Just raise your hand if you have any technical question. I'm very experienced. I can answer any question. And also, don't use all of your binder clip, because save some for later activities. Save some. You only need 12, either 12 or 30, okay? Anything more than that, it's not useful. You are not going to finish it today, so save some binder clip for other polyhedra. Okay, oh, I see you are using colors, you're matching colors. Very good, very good. Okay, very good. Okay. My projector is not, is it still not working? Still not working. It's okay, it's okay. You can try, but I got backup anyways. Okay, I cannot show you the beautiful picture, so I will just explain with words. So imagine a cube in your head. There's a cube. How many edges intersect at one vertex? 3, right? 3 intersect. So you're using 3 things to put together to form one vertex. Is that clear? Is the philosophy clear? I haven't told you how to put things together. So let me quickly build a demo. You will be able to form this, okay? As easy as that. Okay? Okay? No, it's a little bit difficult. It's a little bit difficult. Yeah. Oh, yes, of course. Yes, that one is correct. Got that. Thank you. Thank you. Okay, can you see this? Check this out. Yeah, trying to make a Y shape. Okay, if you have your cell phone ready, you can take a photo when I approach you. Okay. Here. Right. Like this. You're almost there. You're almost there. Yeah, yeah, yeah. And then the last one.
Oh, yes, yes.
By symmetry. Use symmetry. It has to be symmetry, so there is only one choice. Okay. Yes, of course. Like this, like this, like this. Sure. Like this. Okay. See the samples? It's like this, like this, like this. Okay, where is my sample? Where is my? Oh, it's okay. It's okay. So, do you got it?
So
Yes.
please guide us.
Okay.
All these are there.
Sure. Like
How
this.
to attach? Wait. It is so fast. Wait. So come on.
It's just no. Yeah, of course. It's very
Ah,
loose,
that's
but you have to. If you finish one full round, it will be rather solid.
Acha, just to hold like this one.
It'll be rather solid.
Right.
Here.
One month.
This one, okay. Yes, yes, and then one is here, right? And then this one go that one, right? Like this. No, this one have to rotate. Rotate this. So not that. It's like you have the incorrect angle, so it should be this angle, not this angle. This one should be this angle. So let me do it real quick. Okay. Did you get that? Are you there? You there? Okay. Here. This. Okay. You get there? Yes, you are almost there, but this one should be angling inward. This one should be, so these two, you connect these two, right? You connect these two, you connect this, and then you have to connect these two. So, yeah, it has to kind of form a triangle. Yeah. I lost my sample, I'm sorry. Oh, sorry, this is a little bit awkward. Oh, sorry. Oh, you get the idea. All of them have to connect. So this is one vertex, but a cube has 8 vertices. Right. So I'm going to. So let me explain the plane philosophically. In the beginning, we have one edge, and then we make 12 edges, and then we say every 3 edges meet at one vertex, and then I show you how to build one vertex. So this is what it should look like at the end. Okay, you can clearly see that this is an edge, like everything you see is an edge, and then they all meet. They meet at this vertex, they meet at this vertex, they meet at this vertex, and then they meet at this vertex, okay, and so on and so forth. It has to be symmetric, okay? Please be gentle because this is very fragile. This is 2, yes, correct. No, but now you continue, right, like that, okay? Okay, just have a look. This is like a cube, okay? So the first edge goes like, the first vertex goes like this.
No, like this I have taken.
Yes, yes. And then rotate.
Okay.
This is the correct angle, yeah. Your hands are leaning outward. My hands are leaning inward. That this one is more, it's supposed to be more robust. And then, do this, these two are easy, and then you do the last one. Kind of like that. Okay? So here's the, at this point, recording is better. Not just taking photo, recording is better. Yes. Yes, it is very prone to breaking. The whole idea is that if you build everything, it will hold to each other together. But if it's missing one, it breaks. Okay, so that's the idea. So here's the sample. Okay, if you can finish one vertex and then you do this 8 times, that will be an entire cube. Yes. Oh, thank you. How do you do the first 3 here? Insert, insert, and then insert. Oh, that one breaks out, so insert again. Just be patient. Okay, now it's very solid. Here. Very good. So these 2 hands are not connecting, so you have to connect them. Yes, yes. Here, like this. Yeah, feel free to take a photo. If photo is not involved, record a video. Here. Okay. Oh, you want to come? Okay, be gentle, be gentle. I only have 1 sample. Is this, no, because this one is correct. Yes, this one is correct. However, I would recommend that they are far from each other, not close to each other. They're far from each other. And then, okay, there's one detail. They are far from each other from outside, close to each other on the inside. So if you look closely, they are far from each other from outside, but they are close to each other from the inside. Okay. You have to, so this thing is this. You have to do this 8 times. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, okay, so for example, you start with this one and then you continue, right? And then you continue. And then you continue. Right. I'm trying to explain the idea. Yeah, okay. Okay, here's the, check this. No, this, let's see. Here, right? Okay. This one. Okay, this one is good. This one is not. So, yeah, this one is good. Okay, try to replicate this one. Yeah. Also, I will recommend that they are further away from each other, not close. Okay, so further away, not close. Further away, not close. Okay. So here's the sample. Okay, if you want. Okay. Here's the sample. This is second one. Very good. However, it has to be, oh, sorry if I break it, but you have to build it continuously. Like, so you start from 1, right? So that's 1. And then you have to continue building from the one you already have. Right? Like, so now, this is 2. This is also 2, but they are connected to each other. And then you kind of finish the whole sphere. Okay? Here's the sample if you want to check. Okay? Here's the sample. Very good, very good. You're getting the idea. Yes. Yes. So the thing you are holding. Okay, this is correct. This is correct, but this is not, because what is this? This is like 2 edges connecting. There's no such thing on the cube. How do you carry on from there? So if I remove this, right? You okay? This. Okay, this the edge actually looks like this. Okay. Oh no. It looks like, It looks like this, not this. Okay, so you have to replace your edges like this. Yeah.
All of them? The edges, they have to be like that?
Yes.
Not like this?
That one is for another project.
Okay.
Okay, so if you've been here, I mean you're almost there. If you've been here, you continue from this one, and continue, and continue. Now you have what? Now you have 1, 2, 3, 4, 5, and then you complete. Okay? Yes. This is good. Yes, and then starting from you continue building. So this is one vertex. That's one vertex. Now I want to build its neighbor. So here they go. Neighbor, neighbor, neighbor. And now I'm done. Right? And then what? Now what? Now I want to build this guy. So more final clips. You imagine that it's there, and then so on and so forth. Okay? Okay, very nice. Okay. Is my projector working? Can I switch to my laptop? Okay, it seems like the projector is not working, so I'm going to show you another way to construct edges. Okay? If you build this edge, potentially you got this. Okay, each edge is one edge, right? So 1, 2, 3, 4, 5, 6, 7, and then complete the whole thing. That's the idea. That's the, yeah. Okay, so if you try to build this edge, potentially you get this. Okay, each unit is one edge, one edge, one edge, one edge, one edge, one edge. Right, and then if you do 30, that's one dodecahedron. Okay, so here, this one is for you. Okay, so if you build this edge, instead of that one, you will potentially get this one because one edge, one edge, one edge, one edge, one edge, one edge. Right, so, and then like 3 edges meet at one vertex. And potentially it will become a sphere. Like this is only the beginning. I should continue here, 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 right? Yes. So wait a minute. So this one is for you, and then this is the edge. If you build this edge, you can potentially build this. How? Just connect. Here. The vertex, you mean this vertex? Sure. It's the same. You just insert that into insert, and then insert. It's a little bit confusing. It's meant to be confusing. Are you there? Very good. You are very close.
We made it, but one of our guys.
Correct. Okay. Okay. So I'll put this aside. So this is like another way to build things. So I'm sorry I have to break it because you cannot combine two vertices like that. You have to continue from one vertex, like this, like this, like this. And now, look what we have. right? This is like a wall meet at,
If you release it, what happens?
it breaks. Oh, of course, I have to hold it. But if you can build the whole thing, it will sustain itself. Okay. See, you're playing chess. Okay, very good. So, if you try to build this edge, this is what you can do. Okay. If you try to build this edge, you can potentially build this because each edge is one unit. Each edge is one unit. Okay, so this one is for you to study. Hello? Very good. These are not connected. So you start from one vertex, and then you say it grows, you let it grow, you let it grow, let it grow. Okay, now you have this, right? And then it continues to grow. It continues to grow, and so on and so forth. Okay, so that's the idea. Yeah, yeah. Check this out. I have to bring that to the other table. Okay, so this. If you build this differently, so how do you turn this into that? Very easy. Just flip and flip. Okay, and then it becomes this, right? It's like they connect together, connect together, connect together. It breaks, but it's okay. You get the idea. Okay. Okay. So starting from the unit I just told you, you can turn it into this, and then this is the edge unit. Okay, so this one, starting from that one, flip and flip, now it becomes the edge. Okay, and then if you collect 30 of them, it becomes a sphere. Here's for your reference. Please be gentle because it's about to break. Yeah, 3 edges meet at one vertex. Every 3 edges meet at one vertex. And every 5 edges form a pentagon. Then this is a dodecahedron. Okay? Here's for your photo. Please be gentle, it's about to break. Okay, so the idea is that this is what you were taught. Flip and flip, it becomes this edge, right? So flip and flip, this edge, flip and flip, this edge, and then what you can do is you can chain them together to form a vertex. Oh, this is not perfect, I'm sorry. Okay? And then it continues to grow. Right. Okay, thank you very much. Here's the, you've seen it, very good. Okay, this is another sample that you can see.
Like this, sir, every 3 one vertex.
Every 3 meet in one, correct. So these 3, there's a small mistake because they should be like this, not like this. They should, the angle should go this way, not this way. Okay, so if this is correct, then you continue to grow this, and then here, right, and then here, that it grows.
Like this or like this?
You have to make a choice. So it's like all this, or all this. 12 this or 12 that. You have to make a choice.
12 this or 12 this one or 12 this?
12 this one or 12 this one. Yeah. Okay, you can see, very good. And then what you do is you can chain them together like this. Okay, try to replicate that. Okay, this is something. Okay, you're very close. Okay, so there's one thing you need to know. If you cannot connect two vertices together, they have to grow continuously. So they have to. You start from one, and then you grow this way. Okay, grow this way, and then grow this way. And now, what's this? This is just 5 edges. Right. Okay, so if it continues to grow, you can grow a polyhedra out of just binder clips. Okay, here's the sample. This is different. How different is that? So this is what you were taught. Flip, flip, same. It's a line. It's longer. It's straight. 5. So 5 edges become 1 pentagon, 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 pentagon. So if you have 12 pentagon, that's a dodecahedron. And a dodecahedron has 30 edges. So you have to prepare 30 of this.
30 of these 5s.
Yes, yes. Okay, you get the idea, okay? Does the slideshow work? Does the HDMI work? Ah, very good. Very nice. There isn't one way, there isn't two ways. There are actually about 5 or 6 ways you can put binder clips together to form edges. Okay, sometimes you can even form vertices before edges. Okay, so remember that what I have been teaching you is you begin with edges, you let edges meet at vertices, and then you build a polyhedron out of it. So you can turn that around and say, I'll start with vertices, and I will build edges out of vertices, and then I'll grow from there to form a polygon. So this is another way, and then I just want to show you like what's the final product. This is like a very beautiful cube shape. Okay. So I'm going to give you the edge sample. I'm going to give you the edge sample, and then your job is to replicate this. Okay, so this is the edge sample. Edge sample. Edge sample. Edge sample. Edge sample. Edge sample for the thing on the screen. Oh no, it's not on the screen anymore, but you get the idea. Edge sample. Edge sample. This is not done. Edge sample. Okay, edge sample. Edge sample. Edge sample. Edge sample. Edge sample. Edge sample. Okay, edge sample. Edge sample. Here, oh, sorry. Here, edge sample. Ah, very good. Okay, so so one thing you should notice is that you cannot put two vertices like this together because it has to grow continuously. So you have to start from one and then grow like that. Okay, so you cannot do this with this because you can see that these two should overlap with each other. Right? So go from here and then you continue from here, correct? Yeah. So let me try. You're doing a very good job. I don't really want to break that, but I think so. Let me just do this real quick. How many do I have right now? Turn this a little bit, it will make things easier. I didn't mention it because I want to make this challenging. Well, this is still very challenging, okay? So, like this one, and then like this one. Okay, that's two vertices. Okay, continue. And continue. Okay, so that there's a square. You can see a square. Okay, and then continue. Sometimes it breaks. It's okay. Just fix it, and fix it, and fix it, and fix it. Yes, but if you fix it faster than it falls apart, you'll be able to see a cube. Right, this one. Oh, sorry. Okay, so you see the idea. Okay, I'll try until I fail. Okay. So the time's about to end. Can we go back to the slide? Sure. This place. There's one last thing I want to show you. Please be patient. I promise I won't let you down. Ah, very nice. Okay. So the one last thing is that I have a personal website on the left-hand side. I have a personal website, and then I put pictures of binder clips on my personal website. So if you scan the QR code, you'll be led to my personal website, and then you'll be able to see a collection of binder clips that somehow looks like this. I don't have internet access, so this is not my personal website, but it will look like this. Okay? So for the QR code on the left-hand side, you'll be led to this page. And then your job, your exercise for today is to replicate this as well as creating new patterns and new combinations. Okay, that's for the QR code on the left-hand side. It goes more and more crazy as I use more and more binder clips to build things. Okay. On the right-hand side, you see another QR code that leads to my YouTube channel. Okay, so if you scan the QR code on the right-hand side, you'll be led to a YouTube channel that contains video of me making binder clips, so you can see a step-by-step, and then you can slow it down. You can repeat it as many times as possible, so you can see on the screen I'm trying to put them together. It's very frustrating, yada yada. But you can see there's like a very clean cross, and then yada yada yada. And then toward the end, it will make this very beautiful polyhedron. Okay, all on YouTube. Okay, so I hope you have seen something spectacular today. Thank you very much. If you have any question, just let me know.
Thank you very much for bringing us the joy of playing again. The conference ends here, but you can continue playing if you want. Thank you again for, if you have any questions. No questions. So thank you again. Thank you all for being with us, and have a good day.